42 now. Let's stare into the night sky with Dylan Storey. Thanks very much to the Auckland Stardome Observatory. Dylan Storey, good morning. Good morning to you. Yes, and wouldn't be possible without them, really. Today we're talking about the massive blob, perhaps one of the biggest objects in the universe.
Well, I love talking about this thing just because of its name, the Lyman-Alpha blob. And it is pretty much just what it sounds like. It's actually a great big cloud of hydrogen gas. That's it's a long way away. It's 11.5 billion light years away. So that means the light we're seeing from it, the state we're seeing it in, is as it was 11.5 billion years ago.
Right. And
it's very big. It's about 300,000 light years across. And compare that with our galaxy. Our galaxy is about 90,000. So it would fit 3 of our galaxy in it, and it's glowing. And astronomers have known about it since about the year 2000.
Yeah.
But only recently were more discoveries made of it by using the VLT, because we love acronyms so much in astronomy.
What's that?
The VLT stands for the Very Large Telescope.
Is that like a BFG?
Yeah, basically, I always think of it as a BLT.
Yeah, right. Yeah. Okay. Well, what's it made of? I mean, if it's a blob, right? Is it solid?
It's made of hydrogen gas.
Okay.
And so it's been known that it's reflecting light of the spectra of warm hydrogen gas. But the question has been, what is warming it? Why is this gas that's just in the middle of space warm enough to send light all the way across space?
Good question.
So there were 2 theories. One theory was that it's the mass itself was pulling in more gas from around it, which was therefore heating the gas with friction.
Yeah.
And so the gas itself was hot and giving out light. And another theory was that perhaps it could have been heated by extreme star creation events inside it.
Huh.
So perhaps there were brilliant stars burning inside it, reflecting. But light from the VLT needed a very big telescope to collect enough light because it's so far away. So the 8-meter dish of the Very Large Telescope, combined with very sensitive optics, have managed to measure the polarity of the light. And what they've found from the light is polarized. And the only explanation for that is that it's being lit by actual galaxies within it.
Oh, wow. Crazy.
So it's a big blob of gas that contains some galaxies.
So the scale of this thing is just, I mean, it's far beyond what we sort of couldn't comprehend, really. It just would turn your mind inside out if you tried to think about it. But would it be expanding? I mean, the fact that it's made up of this gas, you'd think it would be spreading. It would be getting further apart, right?
Once things get a certain amount of mass together, then they get enough gravity to pull themselves in together. So no, I don't think it would be expanding of its own steam, so to speak. In fact, it's possibly contracting to form a super object. But because this thing comes from the very early stages of the universe, when the universe was only a few billion years old, we don't really know what how it would have unfolded since then. So I guess that's for further observations to try and predict.
Well, yeah, and of course, I mean, it being, 11.5 billion light years away, it could be completely taking on a different form right now, right?
Yeah, it could, yeah. So there are none of these that are close to us.
Yeah.
Possibly, luckily. So none that we can observe more directly. So now that the VLT has discovered this around one of these Lyman-Alpha blobs, there are a few of these known, so it's going to turn its great powers to the other ones to see if the light properties are the same, if the polarization of light is the same, indicating that they are all these great clouds of gas which contain galaxies.
Yeah. Insane. There's a link on the show notes today up at kiwifm.co.nz if you want to find out more about the Lyman-Alpha blob. But it's a perfect time now to be thinking about staring in the night sky with clearing skies over the country and it being so cold and crisp with not a lot of dust hanging around. We should be able to get a pretty good view if we're heading out tonight or over the weekend, right?
Yeah, pretty good, I'd say. Not as good as I've seen it, but I was in at Stardome the other night and looking through the telescopes, and yeah, it was pretty good. Saturn is still visible. It's getting a little bit low on the western horizon, so if you're not quick enough, it'll sort of drop behind the buildings at Stardome.
Yeah.
But the rest of the sky is generally pretty clear. But there's a lot more involved in what makes a clear sky. Like actually, some of the clearest views you get of things is on a rainy day when you get a parting in the clouds. There's something about it. I don't fully understand the atmospheric effects, but something about the rain perhaps clears the moisture out of the lower atmosphere. So when you get a break in the weather, you get this perfect clear sky.
Well, it takes out particles, doesn't it? I mean, I think most hay fever sufferers know that it's they suffer less hay fever straight after rain just because it clears all the pollen particles out of the air.
Yeah, right. Yeah, I'm sure it's something like that, something related to that.
Yeah.
But now the sky, the upper atmosphere is actually slightly hazy, but still pretty good viewing.
Yeah. Okay. Cool. All right. Go along to the Auckland Stardome Observatory for the best possible view. Otherwise, head up to a mountain near you with a wee telescope and give it a go yourself. Dylan, thanks so much.
Just lie there and look at the stars is pretty awesome, eh?
Yeah. Exactly. Talk to you next week, huh?
Cool.
Dylan Storey there. Time now here on